So a car is speeding at a constant speed of 40 meters per second, and it passes a stationary traffic officer on a motorbike, and the traffic officer takes about 1 second to react, and then he accelerates at 5 meters per second squared for 12 seconds. First thing should be a level 1 question almost, and that is to do your conversion from 40 meters per second, so it's 40 meters per 1 second, into 0.04 kilometers, because I convert the meters into kilometers, and the 1 second is 1/3600th of an hour. So I've now got kilometers divided by hours, kilometers per hour. If I want to punch that into my calculator, if I've got a denominator in a denominator, in other words a bottom in a bottom, I land up with 0.04 times by 3,600, and I get 144 kilometers per hour. Then it says determine the velocity of the traffic officer after 12 seconds of acceleration. So he starts off at 0. It doesn't matter how long it took him to react, he still starts off at 0. So I've got an initial velocity of 0 meters per second. I'm interested in his final velocity. I have got an acceleration, and I have got a time for 12 seconds. And therefore I can use V is equal to U plus AT, and it is 0 plus 5 times 12, and simple, I get 60 meters per second. Again, just a level 2 question. Now comes the tricky part. Determine how far behind the speeding car the traffic officer is after 12 seconds of acceleration. Remember to account for the 1 second that it took the traffic officer to react. Truly, in an exam, in matric, they are unlikely to remind you to account for that 1 second. So let's start, and let's get this motorbike going. He's going to go at, distance is going to be 0t plus a half AT squared, and it turns out to be 0 because he started from 0, plus a half of 5 times 12 squared, and that is a total of 360 meters that he has covered in the time. What about the car? The car has been traveling at a constant velocity, so I don't have to use an equation of motion. When we've got constant velocity, we can just use displacement as velocity times time. His constant velocity was 40 meters per second. His time was not 12 seconds, but 13 seconds, and I'll end up with 520 meters. Therefore, the bike is still 520 minus 360, which is equal to 160 meters behind the car. Next one, we've got a cruise ship, and it's being towed out of the harbor by 2 tugboats. One boat pulls with a force of 3,200 newtons on a bearing of 205. So if I've got a bearing, I start from north, I go around by 205 degrees, which really is 25 degrees in there, because it's 180 up until that point, and then just 25 in over there. And it's 3,200 newtons. That's the one ship, whilst at the same time, the other ship is pulling with 2,600 newtons directly south. Define the concept of a vector. Remember, you are going to need to know your definitions. So, a vector is a physical quantity with both magnitude and direction. Then it says calculate the westerly component of the 3,200 Newton force. So I'm looking at components. Remember, components are at 90 degrees to one another. The 3,200 is the diagonal of that parallelogram. I also know 25 degrees. I know that I've got 65 degrees inside over there. The hypotenuse is 3,200. I'm interested in this westerly component over there. So what am I going to do? I've got the adjacent side. I know the hypotenuse, so it's fairly easy. I can say cos of 65 degrees is equal to the adjacent, the westerly component, divided by 3,200, and I land up with that westerly component being equal to 1,352,38 newtons. With the aid of a sketch diagram, determine the resultant force acting on the cruise ship. So now we are going to, it's not quite as simple. We need to draw out, it's a sketch, so it doesn't have to be accurate, but it's 3,200. And I've then got directly south 2,600 newtons. This should be done with a ruler. But as I said, it doesn't have to be accurate. There's 25 degrees in there. Complete the parallelogram. And my resultant is the diagonal of that parallelogram. Once I have that much information, I do know that the opposite sides of a parallelogram, opposite angles of a parallelogram are going to be equal. And therefore, and I also know that the co-interior angles of this parallelogram, that this is 155 degrees. You see, you had to do maths in order to get here. So I now know these two sides, 3,200 and the included angle, so I can use my cos rule and I can say that r squared is equal to 3,200 squared plus 2,600 squared minus 2 times 3,200, 2,600 cos of 155 degrees. Remember from maths that this has to be an included angle. You have to have the two sides on either side of the angle in order to use this cos rule exactly as it stands over there. Otherwise, you've got to kind of go rearranging the world. And when you rearrange this on your calculator, your R does come out to be 5664,01 newtons. But that is not the total resultant. I still need to find some sort of an angle. So the angle I would be interested in, I imagine, is this little one over here, because I could always then add it to 180 in order to get a bearing. So I am going to use my sine rule now, and I'm going to say sine of alpha, which I do not know, over 3,200, which is the opposite side from alpha, is equal to sine of 155 over this angle, the side that I've just worked out, 5,664,01. And when I rearrange all of that, I find that my alpha turns out to be 13,81. You really do need to make sure you can work your calculator, and if you can't, you need to come and see me and we can work out how to punch all of that information in. Now we're going to go, the cruise ship needs to go directly south to exit the harbor, but it's going off course. A third tugboat is requested to help. State the magnitude and the direction of the minimum force which the third tugboat needs to apply to the cruise ship to steer it safely out of the harbor. Well, if I would like to get it to go directly south, I am going to need to pull this in exactly that direction over there, because this is what's happening. So if I can do exactly the equal but opposite thing on that side, I would be able to pull this ship so that it goes towards the south. If it's any consolation, that's 2 marks that are level 4. So I'm going to put this little alpha, this 13,89, in over here. So let's just say that was 81 degrees. So I'm going to say 180 minus 13,81. And I therefore get that this line over here should be 5,664,01 at 180 minus 13,81 is going to be 166,18.